Graphing linear equations. This video will help you identify linear equations and graph linear equations by plotting points. Identifying linear equations. Let's start with a definition. The graph of a linear equation, in this case two variables, is a straight line. And linear equations are always written in the following forms. And here's our first linear equation. This is a generalized form of that equation. So we have some number a times x plus some number b times y equals finally then some number c. And if we take a look down here at an example of that form, I've got the equation x plus 2y equals 4. And in that case, the a value here is 1, the b value is 2, and then finally the c value in that equation is 4. So anytime we have an equation in this form, kind of this ax plus by equals some number c, we are going to get a linear equation, which means we're going to get a straight line. And if you take a look here at the graph of this example I've given you, when we graph that equation, we get a straight line. And that's all we mean here by linear equations. Every time we graph one of these equations, it's going to create a straight line. Now, making that connection between a graph, a picture on a grid, and an equation is a very powerful one. And that allows us to do a lot of different things in math and science, making that connection now between an equation, where we can do some calculations and some computation, and a picture, because a picture then we can translate that to a lot of real-world applications. Okay? The other two kind of forms of this equation, and still kind of the same form, except here we could have a b value of 0, and if we have a b value of 0, that term will drop out, and so we're left with just something times x equals some number. And I've given us an example here of this one. 2x equals 10. And if I was to graph this line, it's going to be a perfectly vertical line. Has no angle to it really at all. And the other version of that is if our b value, our a value drops out, and we're left with a b value, some number times y is equal to some number c. And in that case, you can see I've given an example here. Y equals 2. There's another example of that. Here we get a perfectly horizontal line, and again, no angle. So if we have both x and y in our equation, like this generalized form, our line is going to have some sort of pitch or angle to it. If the y values drop out, we're going to get a perfectly vertical line, and if the x values drop out, we get a perfectly horizontal line. So these are kind of the three forms of the types of linear equations that we're going to be working with in this section. An equation is not linear if a or b have exponents that are larger than 1. So remember, here's kind of our generalized form. Some number times x plus some number times y equals some number c. And so that form right there is a linear equation, meaning if we graph it, we're going to get a straight line. Now, if any of these exponents on x or y is greater than 1, we are going to get if we were to graph the line, we would get a line that is not a straight line. And so I've given us an example here of a nonlinear equation. You notice my a value here is -1, my b value in front of y is 1, and then my c value is 1. But notice I also have this exponent right up here to the second power. And so if I was to graph this, I'm not going to get a straight line. And I actually know how to graph this. I won't go to the details of it, but here's what this graph would look like. Here's kind of a rough picture of the graph I would get. And notice, again, I'm not going to get a straight line there, so this is a nonlinear equation. We are not going to focus on nonlinear equations in beginning algebra, but in the future you will. But for this case, we just got to make sure that all of our equations have variables with exponents of 1. Now let's take a look at examples here that will help you determine whether an equation is a linear equation or a nonlinear equation. So all we're asked for in example 1 here is to determine if each of these little equations I've given you here is a linear or nonlinear. So let's take a look. 5x minus 2y equals 4. That certainly fits the case scenario. A is 5, b is -2, and c is 4. All those variables are to the first power. So yes, that's a linear. We'd say that one is linear. The second one here, you'll notice I have an exponent of cubed here on the second term, and so that's going to make this nonlinear. So we'd say no, that's not linear. Third one here, That one looks a little tricky, but that is a linear equation now. You know, the only thing left really in my generalized form here, it looks like x is part of my equation. So, you know, a would be 1, so that would be 1x, and then it looks like c is 7, and the b term, or the second term, the y term, is dropped out because b is 0, but that's still a linear equation there, so I'd say yes, that's a linear equation. Remember, that's going to give us a perfectly vertical graph when it's in that form. And finally here, same idea again, y equals 14. Looks like my x value is going to drop out and I'm just left with y, but that is still a linear equation, so I would say yes. Okay, now it's time to practice your understanding of linear and nonlinear equations. Go ahead and pause your video player and answer these practice question here, number 1. When you're done, hit play to see how you did. Let's take a look at this first one here. Negative 2y equals 44. There, my x term is just dropped out, but that's still a linear equation, so I'd say yes there. X equals y. Now, that's a little funny looking, but that's still a linear equation. If we came back up here, you know, a is 1, b is 1, and c was 0, but I still have a linear equation there, so yes, that's still linear. The third one here, x equals 7y squared. Well, we got that y squared variable on there. And so anything to the second power is going to give us a graph with a curve to it. So that is a nonlinear equation. So we would say no, that's not linear. Finally, 8x minus 5y equals 7. Yep, that looks like a linear equation. So if we were just kind of like explain in general how these things work, if we have exponents of 1 on our variables of x or y, we have a linear equation, whether I have both variables in there or just one variable in there. The only time we really have an equation that is not linear is if we start to deal with exponents that are greater than 1, like exponents of 2, 3, 4, and so on. Now let's take a look at an example that will help you understand how to graph a linear equation on a rectangular coordinate system. So example 2, we're asked to graph this equation, 2x plus 3y equals 6, and this is a linear equation. Notice both x and y are to the first power. And so what we want to do is we want to take this equation over here and translate this into a picture as a graph. And so the way we're going to do this is just find some points that satisfy or are a solution to this equation, and we're going to plot those points over here on our graph. So the way we usually do this is we make a t-table, and we're going to put in this t-table x first, y second. Since that's the way our ordered pairs appear over here on the graph, I want to make sure we're kind of following that. And so all I need to do now is pick values for x and y that are going to make this, that will make this a true statement in our equation here. Okay? And the way we do that is just pick a random value. Maybe it's not so random, but we pick a value for one of these variables and figure out what the other value must be. Okay? And that seems like a lot, but it's really quite easy. For example, let me say that I started out with a value of 0 for x. And I'm choosing 0 for a couple reasons. 0 is a really nice number to work with because when we multiply something times 0, it gives us 0. But it's also going to wind up on our graph over here. Over here on the graph, I wouldn't want to pick a value for x that's beyond kind of the scope of this graph. So picking a value for x like 40 or something like that would be silly because we couldn't be able to graph it on this graph. So we want to kind of stay within these values. So that's why I picked 0. Now what I'm going to do is I'm going to plug 0 in for x and see what value of y I need to make this a true statement. So I'd say, okay, 2 times 0 plus 3y equals 6. And again, 2 times 0 is 0. That's kind of why I picked it. So that's going to drop right out, and I'm going to be left with this statement, 3y equals 6. Now it's a very simple equation that we could solve. And we see that y equals 2. So there is our first ordered pair, 0, 2. And that point is going to be a point on our graph. So I would come over to my graph now, and I would say, okay, over 0 up 2, there is a point on my graph. So let's double check this point 0, 2 and make sure that it actually is a solution to this equation up here. So let's see, if I put 0 in for x, so I'd have 2 times 0, and then a 2 for y. I want to make sure, hopefully this is a true statement. Well, 2 times 0 is again 0, 3 times 2 is 6. So yeah, sure enough, that point is a solution to our equation. So that's a good point we want to put on our graph. Now with one point, I'm not going to be able to graph a line. We need at least 2 points to graph a line. So I'm going to go and look for another point on this graph. Okay, it seemed pretty easy to put a 0 in for x, so I'm also going to do the same thing now. I could put a 0 in for y and find out what the x value has to be. It's important to be flexible here. We don't want to always kind of keep substituting for x and find y. It actually makes it easier if we kind of substitute at times for both variables. So let's take a look at what my equation would read. Then it'd say 2x plus 3 times 0 equals 6. That 3 times 0 is going to drop out, so I'm left with this. 2x equals 6. Divide by 2. Divide by 2. I find that x is 3. So when y is 0, x needed to be 3. So now let's come over to my graph, and I'll plot that point over 3 up 0. Here's my point. Now with 2 points, I have identified a line. You know, this is a straight line, so I could take those 2 points and draw a straight line. But what we usually do is check one more point. By checking a third point, we made sure we didn't make a mistake. At this point, if I made a mistake, I wouldn't know it. You know, I'd graph these, connect these points together and make a line, and I'd move on. But I want to do kind of a third point kind of as a checkpoint. And so maybe I'll just try, let's see, x is 1. Just come up with that value, still again staying on my number line. 1's kind of an easy number to check. So I'm going to put a value of 1 in there. Let's see, so then I have 2 times 1 plus 3y equals 6. Okay, so 2 plus 3y equals 6. Subtract 2 from each side. 3y equals 4. Divide by 3. And we don't have to worry that this isn't going to work out to be a nice whole number. 4 divided by 3, we don't want to leave that as an improper fraction. Let's turn that into a mixed number. So that would be 1 and 1/3 if I'd looked at that as a mixed number. So let's see, I get the point 1 and then 1 and 1/3. Let's come over to my graph now and graph that point. So over 1, up 1 and 1/3, and I'm just going to kind of estimate that third. It's probably right about there somewhere. But this point was really just a checkpoint anyways, and you can see now that this has worked. I have not made a mistake because all of these points are lining up. Had I made a mistake, I would get points that wouldn't have lined up, and I know I got to kind of go back and check and make sure that I did my arithmetic correct over there. But since these are all lining up now, what I can do is I can graph a line here through those points, and I want to put arrows on the end of that line. Because what that line represents is it represents all the solutions to this equation up here. So every point on that line is a solution to that equation. And this line is going to continue on forever. There's going to be an infinite number of solutions to this equation over here. And that's always going to happen when we have 2 variables in our equation. So when we get done making our graph, we want to make sure connected points and then go ahead and put arrows on the end to say that this line is going to go on forever. Now it's time to check your understanding of graphing a linear equation in 2 variables. Go ahead and pause your video player and answer this practice question. When you're done, hit play to see how you did. Okay, question 2, we're asked to graph this equation 2x minus 3y equals 6. So we'll start with a t-table. Pick some values for x and y. Again, I think it's easy to kind of start by picking a value of 0. So if we put a value of 0 in for x, then I'd have this, 2 times 0 minus 3y equals 6. So then I get negative 3y equals 6. Divide both sides by negative 3. Y equals negative 2. So there's my first ordered pair. Second order pair, let's put a 0 in for y. And so let's see, then we have 2x minus 3 times 0 equals 6. So really I'd be left with 2x equals 6. Divide both sides by 2. We get an x value of 3. Now let's try a checkpoint. And let's see if we can come up with a nice whole number. We might end up with a fraction, but maybe not. So I'm thinking, okay, I want to put something in here for x and subtract 3, some multiple of 3 from it to end up with 6. Let's see, maybe if I put a 5 in there for x, that would give me 10. 10 minus 3, no, that's 7. Let's try a little bit higher. Maybe if I put a 6 in there, that would give me 12. And I could do 12 minus, I can get a multiple of 3 to be 6. So I'm kind of just doing some calculations there. But I kind of figured this out. If I put a 6 in there for x, that's going to give me a 12. Let's take a look. And if you're not following along with me, that's okay. You can just put values in there to figure it out. But I kind of saw this, that if I put a 6 in there, I would get 12 here. And I knew that I could subtract some multiple of 3 to get 6. And so that told me that I really kind of needed a 2 in there for y, because then I could think 12 minus 3 times 2 is 6. 12 minus 6 would give me 6. So that's how I came up with that point. And that's kind of a little bit advanced thinking, but I wanted you to be aware there's some kind of combinations here when we're making these, defining these solutions. Sometimes you just check some values till you come up with the right combination. So there was my third point. Let's go ahead and graph these points now. So over 0, down 2. Here's one of my points. Over 3, up 0, 1, 2, 3. And finally, that last checkpoint that I chose was 6, 2. So over 6 and then up 2. And now, since my points are all lining up, all 3 points, that tells me that I haven't made a mistake here, and I have confidence in this graph that I'm about to make. Okay? So I would graph that. And so you may not have chosen my points, the same ones that I did, but your graph should still look the same as the one I've graphed here. So here's kind of a tip on how to work smarter when we're picking values and trying to come up with these values for our graph. And so one tip or technique here is to always pick values for the cluttered variable. So notice if I'm looking at this equation, I have y equals 6x. This is a linear equation. If I was going to graph this, I'd make a t-table. And so my tip for you is always kind of pick values for the variable that's cluttered. If I pick values for x here, and by cluttered I mean the one that has some multiplication or some addition or something like that happening to it. If I pick values for x here, it's going to be really easy to see what the value for y would be. For example, if I picked a value of 2 for x, I can quickly see when I put a 2 up in here for x that 2 times 6 is going to give me 12. And it makes it really easy to kind of come up with these values. Again, if maybe I picked a value of 1 for x, I could see that 6 times 1 is going to give me 6, or a value of 6 for y. It's not so easy if I was to pick a value for y and try to work back the other way around. For example, let's say I picked a value of 4 for y. Well, then I would have this equation, 4 equals 6x. Not nearly as easy to figure out, you know, and I didn't even end up with a whole number there. I divide both sides by 6, divide by 6, and when I simplified the fraction 4/6, I'd end up with 2/3. You can see how this is kind of getting messy and ugly. But if we pick values and substitute those in for kind of the cluttered variable, the actual process gets a lot smoother and a lot easier. All right, so let's go ahead and practice this idea I kind of just showed you about working smarter. So we're going to graph this equation, y equals 4x minus 2. And so go ahead now and pick values for the cluttered variable, which in this case is x. You can plug values in for x here, and a lot of times you can do the calculations mentally to see what the values for y need to be to make this a true statement. So go ahead and pause your video player and graph this equation. When you're done, hit play to see how you did. So I want values for x and y. X is kind of the cluttered variable, so I'm going to kind of plug numbers in for that. Let's say I put a 0 in for x. If I put a 0 in for x, I'd have 4 times 0, which is 0. So this is kind of what I'm thinking, and I would do all of this mentally. You know, I'm plugging a 0 in for x, and I would say mentally, you know, 4 times 0 is 0. Well, 0 minus 2 is just negative 2. So we're going to end up with a y value there of negative 2. Let's pick another value for x, maybe 1. And so, again, I'll write this down, but this is what I would do kind of mentally. I would think 4 times 1 is 4. Well, 4 minus 2 is going to give me 2 for my final value there. Now let's just get one more point, a final checkpoint. Let's say we can put negative values in there as well. So how about negative 1 as a value? Well, this might be harder to see, but again, I would still do this kind of mentally. 4 times negative 1 is negative 4, and then negative 4 minus 2 would give me a negative 6. So now that I have my 3 values or 3 points, I'm going to go ahead and plot these. So the first one was over 0, up, down negative 2. The next point was over 1, up 2. And my third or checkpoint was to the left negative 1, so I go left 1, down 6. And again, my points are all lining up there on a straight line, so I have confidence that I've solve this thing. And so you may not have chosen my values, but again, your graph should look like mine. So another working smarter tip when we're graphing linear equations is if we have a fraction in the equation, like we have right here, this fraction 2/3, and fractions can be a little bit problematic, as we all know. If we have a fraction in here, we are going to want to pick values that are multiples of the fraction's denominator. So notice x is my cluttered variable. So in this particular one, I'm probably going to pick values for x, but I also want to pick multiples of this fraction that's next to it, because this 2/3 is getting multiplied by x. And if I pick multiples of 3, this fraction is going to drop out, very similar to what we did with the LCD method. This fraction will drop right out of there. Let me show you what I mean. So let's say I'm over here. Here's my x, my y value. I know I'm going to be multiplying by this 2/3. So this denominator of 3, I want to pick values that are multiples of 3. So multiples are just going to be, 3 times 1, 3 times 2, 3 times 3, and so on. So the first thing I would do is take 3 times 1, or 3 itself. There would be my first multiple of 3 to plug in there. And let me show you what happens when I take a multiple of 3. So then I'd have y equals 2/3. Since I'm multiplying this x value of 3, I'm multiplying it by a fraction. Let's write that value as a fraction itself. So that 3 is really just 3/1. And then I'd have plus 1. And now you can see that multiple of 3, I'm just going to have those common factors of 3 divide right out, and I'm left kind of with this. Y equals 2 plus 1, or y equals 3. But again, that fraction dropped right out of there for me. So let's see, another multiple of 3. Well, 3 times 2 is 6. Let's see what happens if I put a 6 in there. So then I have y equals 2. Okay, so we're taking a look at 6. So I'd write that 6 as a fraction. 6/1. Okay, plus 1. And now you can see here a common factor of 3 dividing out. The 3 is going to divide out. When we divide a 3 out of the 6, we'd be left with 2. So I'd be left with y equals 4 plus 1, or y equals 5. Okay, so picking multiples of this fraction's denominator is going to make this a lot easier. So try to do that anytime that there's a fraction in one of our linear equations that we're trying to graph. Okay, now it's time to practice that idea. We've got a graph of a linear equation here, and I've given you a fraction with a denominator of 5. So notice x is our cluttered variable, and we've also got to get rid of this denominator of 5 as we're substituting values. So when you're picking values, go ahead and pick multiples of 5 for that x value, and watch those fractions drop right out of the equations as you're going to solve for y. So go ahead and pause your video player and graph this equation. When you get done, hit play to see how you did. Okay, so I want multiples of 5. So 5 is probably good. 10, if we went to 10, we're kind of going to go off the scope of our graph here. Notice in the graph it only goes to 6. So I probably don't want to pick 10, but I can pick negative 5. That's a multiple of 5. Negative 1 times 5 is negative 5. And I think finally what I would also pick here would be 0. 0 is always an easy number to pick. So those are my 3 x values I'm going to try. Let's go ahead and find these out now. So the first one, when I put a positive 5 in there, I'd have this. 1/5 times 5/1 minus 2. So the 5s are going to divide out nicely for us. Remember, there's a 1 left over every time I divide that out. So I'd have 1 minus 2, or y is just going to be negative 1 for that value. Let's see, 1/5. Let's pick a value of negative 5, so that would be negative 5/1. Okay, the 5s divide out again, and now I'm left with 1 times negative 1, or negative 1 there. So negative 1 minus 2 is going to give me negative 3. And then finally that 0, if I had 1/5 times 0 minus 2, well, 0 times anything is 0. That's dropping right out, and we see that y is equal to negative 2. So there are my 3 points. I'll go ahead and graph them. So over 1, 2, 3, 4, 5, down negative 1. And then to the left, negative 5, down 3, And then finally 0 in the x direction, down 2. And because my points are lining up, I know I've done this correctly, so let's see. Okay, so you may not have chosen my points, but your graph should look like the one I have graphed here.